A hockey puck is launched at an angle to the horizontal, and our job is to find the max height that the hockey puck goes and the total horizontal distance the hockey puck goes. Now we have an angular projectile, so the first thing we do is break this into Vx and Vy. This will be the Vx going in this direction, and Vy will be in this direction here. So let's get started. Vy will equal 27 times the sine of 19, and that equals 8.8 meters per second. And Vx is going to equal 27 times the cosine of 19, and that equals 25.5 meters per second. Okay, let's find the distance this goes in the x direction first. Now, if we look at x direction, now all we have is a velocity equal to 25.5 meters per second. We do not know displacement, and we do not know time. Since there are two unknowns in the x direction, we turn to the y direction first. So y direction, we know that velocity 1 is equal to 8.8 meters per second. Now, because this hockey puck goes up from the ground and returns to the ground, we actually do know V2. V2 will be negative 8.8 meters per second. And this will be true for any projectile that's launched from a certain spot in the y direction and then returns to the same location in the y direction. Your beginning velocity will equal your final velocity, with the exception of a negative, because it's going downwards when it returns. Acceleration equals negative 9.8 meters per second squared. Time is something we're going to find. And lastly, displacement, we don't know. Now, there are a couple ways that you can use to find the time. We can start with the V2 equals V1 plus AT equation. So minus 8.8 equals 8.8 plus a negative 9.8 times time. Now this, of course, will be the easiest way of doing it. We do have another way of doing it, and I'll show you in a moment. So time is equal to 1.8 seconds. The other way of doing it is the d equals v1t plus 1/2 at squared equation. Now here we'll plug in 0 for our total displacement because it goes up and then all the way back down in the y direction. So 0 would be the total displacement. So 0 is equal to v1, which is 8.8 t plus 1/2 negative 9.8 times t squared. You can either factor this or use the solver in your calculator, and time will still equal 1.8 seconds. Okay, now we record the 1.8 seconds here. And now we can use d equals vt, so displacement equals 25.5 multiplied by 1.8. And the horizontal range, or the distance it goes in the x direction, is 46 meters. Okay, now what about maximum height? Well, there's a variety of ways of doing that. Let's just keep consistent with chapter 2 and use the v2 squared equation. Now we don't know what our displacement is, so that's back to a question mark. So let's just use the v2 squared equation. So 0 squared is equal to 8.8 squared plus 2 times negative 9.8 times d. Now you might be wondering, where's the 0 coming from? Reminder that at max height, 8.8 would not be true any longer. It would actually be 0 meters per second, because at maximum height, the velocity would be 0 in the y direction. So then our displacement, our max height in this case, would be 3.9 meters. And those are our two questions there. Again, if you're trying to find the horizontal range the projectile goes, you really need to find time it takes to go up and all the way back down again. Whichever method you choose over here is fine. And then when doing maximum height, just a reminder that velocity to at max height in the y direction would be equal to 0.